Hello, welcome to day 6, converting polar equations. Today we're going to be looking at polar equations and converting into Cartesian equations. Polar equations have r's and thetas. Cartesian or rectangular have x's and y's, or we might do vice versa. So we start today. We can start with our key, and we have the big four that we're going to use. Some review, the idea that secant is 1 over cosine and cosecant is 1 over sine. But these big four equations that we used before are key. We need to think about how we're going to use these equations. We're going to use as substitution. So this guy came from doing r was equal to x squared plus y squared, and this guy came from theta was inverse tangent of y over x. But we have used these before. So going back to Cartesian, if I ask you to graph, what does x equal 5 mean, and what does the graph look like? Well, the graph, if I graph this, it will look like this. We would have x equals 5 because it is a vertical line in which every point has an x value equal to 5, and it could have any y value. That's what x equals 5 means. It's a vertical line, and every point is going to be 5 comma something. As opposed to, let's go to polar coordinates. What does theta equal 45 mean? Well, if I would graph it, the graph would look something like this. Let's say I have my grid. The polar grid kind of really looks like this. Kind of has, let me see if I can pick something really light, like a gray. It really has kind of this dartboard grid to it. Has these angle lines all over the place. So if I had a graph theta equals 45 degrees, well, that graph would look like this. This is theta equals 45 degrees. It is an oblique line or a slanted line in which every point has a theta equal to 45 degrees and any r value that you want. Every point on this graph is going to be some r value comma 45 degrees. So now we're going to work on converting these polar equations, r's and thetas, into Cartesian equations, x's and y's. How do we do that? We're going to manipulate. So we can use the big four on the top of the page here. I want to get where I like having something like an r squared, because I have a substitution for that, or I like having y over x, or a tangent of theta, or r cosine of theta, and all this and that. I'm going to manipulate the whole situation by using my rules of algebra. Okay, I'm going to stretch this a little bit. Okay, my first example here. I like having r squared. So one way I can get r squared is to square everything. So I get r squared is equal to 16 cosine squared theta. And this I like, because I have a substitution for that. But that I like, this I have no idea what to do with. So to me, this was a bad choice. It's okay. I can erase it and try something else. How about if I multiply everything by r? I get r squared equals 4r cosine theta. And that, to me, is something I can work with, because when I substitute in stuff, r squared becomes x squared plus y squared from the top, and 4r cosine of theta becomes 4x. And now I want from r's and thetas to x's and y's. The whole point is I start with r's and thetas, and I ended up with x's and y's. Now, hopefully you know what this looks like. This is a circle. We should really work on what these graphs look like. Anytime you have x squared plus y squared is equal to blah, 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 that will be a circle every single time. And I can even show you that it's going to be a circle. I'm going to show you that this is a circle. I cannot put x squared plus y squared equals 4x into my calculator, but I could definitely put r equals 4 cosine theta into my calculator. So here's my calculator. I can clear this out and do 4 cosine theta, and I can graph it. I've already set up my window to be good, and there we go. It is a circle, and it looks like its center is 2, 0, drawing twice. Okay. Okay, this next problem, I have 4 secant theta. There's no substitution for that, so what I can do, I can rewrite it as r equals 4 over cosine theta. And then I can use ideas of algebra and multiply both sides by cosine theta. I get r cosine theta is equal to 4, because the cosines on the other side cancel out. And then, oh, look at that. R cosine theta, that is just x equals 4. That, you should know, is a vertical line. And I'll show you on the calculator how it's a vertical line by plugging in the polar equation. Of course, we all know that x equals 4 is a vertical line, but I want to show that r equals 4 secant of theta is also a vertical line by showing on the calculator. Now, I cannot put in 4 secant of theta, but I could definitely put in 4 divided by cosine of theta. And when I graph this, I do get a vertical line. It's kind of weird. It starts on the x-axis and goes all the way up and completes the process. So this next problem, I don't really have a simple fix for theta, but I could take tangent of both sides, and I get tangent of theta is equal to tangent of 30 degrees, and tangent of theta can be replaced with y over x. That is one of my substitutions from the Big Four. And tangent of 30 degrees is 1 over radical 3, or you could do radical 3 over 3, they're the same to me, and then I'm going to multiply both sides by x. I get y equals 1 over radical 3 times x. 1 over radical 3 is just a number like 1/3 or 2/3 or 8 over 5 or anything. This is an oblique line. It is a slanted line that runs through the origin. Actually, this next example is pretty darn easy. I like having r squared, And I could just square both sides, and I get r squared is equal to 4. I have a nice, easy substitution for r squared. R squared is just x squared plus y squared is equal to 4. And again, anytime you have x squared plus y squared, this is a circle. Notice when I converted these r theta equations into Cartesian x's and y's, I don't always have to solve for y equals. Sometimes it's easy to do that, like in number 3, but in other problems, number 2 I couldn't do it at all, and number 1 and number 4 it wasn't really necessary. So on this page, I'm going to do it the other way. I'm going to start with x's and y's, and I'm going to convert it to equations with r's and thetas, and I'm going to try, if I can, I'm going to try to get it so it says r equals blah, blah, blah. I might not always be able to do it, but I'm going to try my best. Well, the very first problem, look at this. X squared plus y squared is a nice substitution. That's just r squared minus y has a substitution of r sine of theta. Again, I'm using those big 4 from that front page. I'm going to add this over to the other side. I have r squared is equal to 2r sine of theta. And then I could divide everything by r. I get r equals 2 sine theta. Well, I told you at the beginning, anytime I have x squared plus y squared, this is a circle. But again, I could put this in the calculator, r equals 2 sine of theta, and I could show you that it is a circle. Okay, I'm on my graphing calculator. I've set it 2 sine theta. I already have my window set, a 0 to 360 for my theta min to max, and I have my theta set for 2. The bigger I make it, the worse it is. So I made it something small like 2, and I just hit graph. And it's going to go a little bit slow, but there it is, drawing a really tiny little circle. Looks like a radius of 1, centered at 0, 1. Okay. Okay, problem number 6. Nice easy substitution. Y is just r times sine of theta is equal to -3, and then I can just divide by sine of theta, and I get r equals -3 over sine of theta, or -3 cosecant of theta. You don't have to rewrite it that way, but it's a little bit neater. Y equals -3 is a horizontal line. Notice in 5 and 6, I started with x's and y's, and I finish up with r's and thetas. Okay, number 7, again we have some easy substitutions. I could substitute in for x and y, but I'm not going to. I know if I divide both sides by x, I get y over x is equal to radical 3. Why do I like that? Because I know from the big 4, y over x is a very nice substitution. This turns into tangent of theta equals radical 3. How do I undo tangent? Well, when I want to undo tangent, I do inverse tangent on both sides of the problem. I have theta equals inverse tangent of radical 3, and I should know that already, or I could plug it in the calculator. I get theta is equal to 60 degrees. Well, theta equals 60 degrees is just an oblique line. But I should have known that from the beginning. When I had y equals some number times x, you know that's just a diagonal or slanted type of line. Okay, this next problem, a little bit different. xy equals 10. If I resolve this, I get y equals 10 over x, and you should know that as a parent graph as this. That graph has a special name. We'll talk about it in a minute. But now I'm going to do my substitutions. R times cosine theta is the x. r times sine of theta is a y, so that equals 10. So I get r squared equals, times cosine theta times sine theta is equal to 10. I'm going to divide it out. Cosine theta sine theta, r squared is equal to 10 over cosine theta sine theta. Then I could just take the square root of it all. I get r equals the square root of 10 over cosine theta sine theta. And this graph, this name of this graph is called a hyperbola. I'm going to put this purple equation into the calculator because I want to show you that I should get the same looking graph as I did before, 10 over x. As you can see, I'm back in the calculator. I'm in my polar mode. I typed in what I got as my square root of 10 over cosine theta sine theta. And I'm going to hit graph, and hopefully I get that hyperbola looking graph. And there's the right branch, kind of disappears, and there comes the other branch. So even though I didn't type in y equals 10 over x, I still got the same graph. Okay, 2 more examples. This one's going to be a little bit more algebra work. These last 2 are going to be a little bit more algebra work. The first thing I should do is that when I see this and this, I should expand them. So x minus 3 squared is x squared minus 6x plus 9. And this turns out to be y squared plus 4x plus 4 equals 13 when I expand them. Remember, lost everything. There we go. I can't believe I just lost everything. Okay, sorry about that glitch. Sometimes this is sensitive. X minus 3 squared is x minus 3 times x minus 3, and that gives me this. Okay, I'm going to reorganize it. X squared plus y squared minus 6x plus 4. Terrible. That should be a y. Or y, 9 plus 4 plus 13 is equal to 13. Okay, sorry about this. I kind of got goofed up. But hopefully you can bear with me. So now I have x squared plus y squared minus 6x plus 4y plus 13 is equal to 13. I could cancel out some things. These two are going to cancel out. I do that. This is 13. Those go away, so I get it equal to 0. These two become r squared minus 6 r cosine theta plus 4 r sine theta. We got a situation where I went from x's and y's, and now I'll have r's and thetas. I'm going to bring these two to the other side. And when I do all that, I get r squared is equal to 6r cosine theta minus 4r sine theta, and divide everything by r, and I get r equals 6 cosine theta minus 4 sine theta. Of course, at the beginning, when I told you ever have an x squared plus a y squared equals blah blah blah, it is a circle. I hope you can follow along on this problem. I'm sorry I hit some glitches. It happens sometimes, and I can't rewind. If you are ever unsure of what the graph should look like, you can just type it in, if you can, in the polar mode. In this case, r equals 6 cosine theta minus 4 sine theta. And when I hit graph, I do get a circle. No longer is it centered on the x or y axis. We'll talk about where the center is going to be at some other day. Okay, and finally, this last problem, 3x plus 4y equals 2. I hope you know what that graph looks like from Algebra 1. I have nice easy substitutions for the x's and the y's. 3r cosine theta plus 4r sine theta is equal to 2. I'm going to have to factor out an r. So I got r, parentheses, 3 cosine theta plus 4 sine theta is equal to 2. I can't divide out r like I did at other times because I have a 2 on the other side. I could divide out by r when I have a 0 or things with r's in it. I can't do it here. But now I can just divide out by 3 cosine theta plus 4 sine theta. And I get r equals 2 over 3 cosine theta plus 4 sine theta. And according to this original equation in x's and y's, you should recognize that as an oblique line.